What we're going to do now is we're going to take a look at the ex3 example, which will show how to apply various RxJava features asynchronously and concurrently to reduce, multiply, and display big fractions using various single operations. And the key thing that's going to be different here is it's going to demonstrate the use of zip width, which is kind of a fun example. And it'll also show how to use the parallel thread pool. So as you can see here, we only have one method that we're going to be testing here, but we still use our async tester framework just because it's convenient and consistent. So let's go ahead and look at the code. And here is the method. This is called test fraction combine. And what it's going to do is it's going to start by making a new random number generator. And then we're going to go ahead and call a factory method called make big fraction, passing in the random number generator. And it's going to go ahead and make a big fraction. And it's going to do this asynchronously. We'll take a look and see how that works in a second. So as you can see, we're going to go ahead and make two big fractions asynchronously. And then we're going to have a local variable that's a consumer called mixed fraction printer. And now what we're going to do is we're going to use zip width. And what zip width is going to do, much like then combine did in our completable futures example, is it's going to wait for M1 and M2 to both finish. So we're going to be doing the creation of a random big fraction and multiplication of it. And then when we're done, when both of those computations are done, then the results will be added together. And then we're going to go ahead and print them. And we give back the ignore element completable just so it'll work properly with the async framework in the background, async tester framework. Here's the make big fraction method. As you can see, what it's going to do is it's going to call single.just, and that will go ahead and make a big fraction and multiply it. So it makes a big random big fraction. And we're going to print it after it's multiplied just to give some results. And then we're going to use the subscribe on method. Now, again, I could put subscribe on here. I could put subscribe on there. It doesn't really matter. It can go either place. And so the point is that whenever this method is called, make big fraction, it's going to return a single to a big fraction that is going to run in the background to do the creation and the multiplication. And then zip width is going to be used in order to wait for those things to both finish. So let's go ahead and run this thing, and it'll go ahead and start up and create the two big fractions. You can see that this computation is taking place in the background. So these are the thread IDs where things are getting printed. And this is the first big fraction. This is the second one. They go ahead and do the multiplication and the creation of multiplication in the background. And then we add the results together. And you can see that 9 plus 22, and then this ridiculously long, look how long that is. This ridiculously long big fraction will end up with the final result, which is 31, and that ridiculously long big fraction portion. So that's basically how we run that particular test. And I want to show you something else too, because I just don't think I showed it before, or I didn't pay enough attention to it. So let's go over here and let's run the first program. This is the first one we did. This is the single EX1 example. And you can notice that in that case, everything ran in the main thread of control. So it was always running in the calling thread. And then all the other examples that we've looked at henceforth have been running things in the background threads. And so, of course, when we run those, we get different results, or threads are printed in different ways because they're running in the background. So you can see here, in contrast to the one I just ran, the results here, and you can see it was a very large big fraction. Very, very, very large big fraction. You can see that that's taking place in the background. And you can see that by looking at the thread IDs. Look at the size of that big fraction. That's a pretty hunking big fraction. Okay, so that's basically what I wanted to cover in terms of the single operations. And so some of the key things to remember from all these discussions is that you can use subscribe on in order to get computations to run in the background. And then there are also various other methods that you can use to do computations that will get the results immediately, like just to kind of work as a factor method to get a non-reactive value into the reactive world. There's from callable, which can be used to do the same thing, except that it's going to work with supplier so it can have different values each time. And when we start talking about observables in the next class, you'll see how the observables have many of the same methods, but rather than working on one of something, they work on a whole sequence of things. So that's the main difference between singles and observables. Observables work on a sequence of things, whereas singles work on one thing.